Calculate the density of helium in a helium balloon at 25 Celsius. Assume the pressure inside the balloon is 1.10 atmospheres. So we've got pressure. We've got temperature. However, when we're dealing with gases, we know that the temperature we have to work with is pretty much always going to have to be Kelvin. So I'd have to add 273.15 to that to get to Kelvin. It's going to be 298.2 Kelvin. So really it would be 298.15. But when I add and subtract, I have to line up the decimal places. So since I don't have a number in the second decimal place for my initial temperature, I can't have a number in the second decimal place in my answer as far as sig figs are concerned. So I've got the temperature now in Kelvin. I've got the pressure given to me. And so sometimes even before I even look at what the question is asking, I'll just write down the given information so then I know what I'm working with. Then it says calculate the density. So what units do I want if I'm dealing with density? I want mass. Density is mass per volume, right? It's how much matter is packed into a given amount of space. So if I want density, it doesn't say exactly what units to use for density, but it has to be some mass, which would normally be grams, per some volume, which would normally be milliliters, or I could do grams per liter if I want. If I'm dealing with a gas, then usually, it doesn't really matter. It's density if it's grams per milliliter or grams per liter, but for gases, since their densities are so low, often it's reported in grams per liter instead of grams per milliliter. And since the ideal gas law requires me to work with liters anyway, it's probably easier to get grams per liter than to get the liters and then convert them to milliliters. So, like the last question, I'm trying to calculate a quantity here that has 2 units. 1 unit per another unit. So that means when I plug things in to get this quantity, I'm going to have to plug something in on top that I can convert to grams. Or if I have grams directly, plug that in on top. And then I have to plug something in on bottom that I can use to convert to liters. Or if I have liters, I can plug that directly into the bottom. So how do I get these quantities? What can I do here? So if I think about I've got pressure and temperature, so I probably want to start thinking about the ideal gas law. So what I've got here is pressure given to me. I've got temperature given to me. I always know the value for R, but I don't have the moles given or the volume. I don't really have any other given information. I don't even have information I can use to convert to moles or convert to volume. So how do I use a formula if there's 2 things I can't plug anything in for? What can I do here? I can't really convert the atmospheres to grams. I don't really have any relationships that will allow me to do that. That would be nice if I did, because then I could plug those grams in on top here and start to calculate the volume and plug that in as well. If you have a formula and you don't have all the variables except one, you can't really solve the formula for just one variable. But you can rearrange it to get all of the knowns on one side and all of the unknowns on another side. And so that's what we need to do here. What we'll recognize is if I want the quantity of gas per volume of gas, I want to rearrange the ideal gas law to get the quantity of gas on top divided by the volume of gas. So if I rearrange the ideal gas law here, I can divide both sides by the volume. That will cancel. And then I can divide both sides by RT. So that will cancel here. I'll have N over V equals P over RT. And so the point of doing that is because I recognize that moles over volume is very similar to what I want, which is grams over volume. If I can calculate this quantity by plugging in pressure, R, and temperature, which I have all of those, I'll have a number that represents the moles per liter. And that's very close to what I want. Then I just have to take the moles I have and convert it to grams. So I would use that formula. I want to get moles per liter. Plug in the pressure that's given, 1.10 atmospheres. Divide that by R, 0.08206 liter atmospheres per mole Kelvin. Divided by the temperature that I have in Kelvin, 298.2 Kelvin. So the kelvins will cancel, the atmospheres will cancel, and I'll have moles per liter, which is exactly what I want if I'm trying to get grams per liter. So when I plug that into my calculator, 1.10 divided by 0.08206 divided by 298.2, and I get 0.04. So I've got 3 sig figs, 495. I'll keep an extra sig fig for now because I don't want to round until the very end anyway. So that's the number of moles per liter. So if I want grams per liter, that's what I'll start with. Then I just have to convert the grams into moles. And so I need the substance I'm dealing with to do that, so I can use the molar mass in the periodic table. The substance I'm dealing with is helium. And so helium's molar mass, 4.00260. That's the number of grams of helium equal to 1 mole of helium. The molar mass gives me the grams per mole relationship. So if I want moles to cancel and I want to get grams, I'll put the 4.00260 grams on top, equal to 1 mole of helium. The moles will cancel. And now I've got grams per liter. That's exactly what I wanted. So then I would just plug that into my calculator. And as we said before, I am limited to 3 sig figs. So this is when I want to round, 0.180 grams per liter.